All right. Good evening, everybody. Welcome to tonight's episode of the Astro Imaging channel. Tonight we have with us Charlie Bracken, who's going to talk about his quest to image an incredible number of objects. I think I have 1,700 written down somewhere, and how he's done it all so that you don't have to. Yeah, he gave this talk at NEAC. It was quite entertaining, so glad to get to show that to you guys. Before we hop over to Charlie, I did not pull up our calendar, so let me just do that real quick so I can remember what we have coming up here. Okay, so we're normally first and third Sundays now, but because of the 4th of July holiday weekend here in the US, we're not having a show on the 5th of July, which is the first Sunday. So, but we are back on the 19th of July with Nick Loveday about the ASI Air, the missing manual. So all about how to use the ASI Air well. And then we'll be back on the 26th of July for a special out of cycle episode. The timing worked out better. Plus we're a little short on July episodes, to hear from user Vin, who is going to talk about, actually, I don't entirely know what this talk is about, but it's can silicon-based intelligence help astrophotographers that got cut off? Okay, but that should be really interesting to see. I'll have more information out about that here soon. And then on August 2nd, we have Bruce Herwig talking about star trails and satellite tracks. And then we've got a couple of open weekends. So if you would like to reach out to us and to let us know that you're interested in giving a talk. I know sometimes we're not the fastest at getting back to people, and I apologize for that, but we'll get back to you. That's the astroimagingchannel.org, and the contact us button will let you send us an email, let us know if you're interested in giving a talk. Yeah, let's see. Okay, we will call that there. And we'll pass it over to Charlie.
Awesome. Thank you so much for having me again. It's good to be back. Yeah, so the story tonight I want to tell, let me bring up my slides, is imaging a whole lot of deep sky objects, hopefully, so you don't have to. In the process of imaging all the things that are worth imaging, I captured quite a few that really aren't that great. But we're going to go through the process that I went through in writing my latest book, and the journey that I went on over the past 5 years for that. So you haven't met me before. I'm Charlie Bracken. So I've written several books on astrophotography, the Deep Sky Imaging Primer being my main book, which is a how-to image, like how to get started. The latest book is Astrophotographer's Universe. That's the journey I'm going to talk about today, but have a couple other books as well. There's my website, Astrobin, and you can always feel free to reach out and use old school email if you like. So the premise of today's talk fundamentally is that my problem is that I can't stop. So once I get started on something, I feel like I really, really need to complete it. So this has happened a couple of times where the first example is that we started, Max Whitby and I started creating this mosaic, and the original idea is, we'll just create a mosaic and capture the center of the Milky Way in this beautiful area. Well, okay, what if we just kept going and we captured the rest of the Milky Way? Well, what if we just kept going and captured the whole sky that way? So that's what we ended up doing. I think I was actually on this channel a couple years ago presenting this image. So ended up with a gigapixel image, 0.2 arc second resolution, or 0.2 arc minute resolution of the entire night sky. This is the hydrogen enhanced RGB version of it. So this was 500 hours of exposure time, 153 panel mosaic, but I just couldn't stop at the Milky Way. I had to cover the whole sky. This was featured in the book I wrote with Max, The Visible Universe, and the goal there was to pick 110 representative, really nice objects that you might want to go image, 110 sort of being an homage to the Messier Catalog. And yet again, I'm at 110, and I'm like, well, I've got these other images, I got these other ideas, I got things I want to write up. And so the thought occurred to me, I wonder if I could capture all of the deep sky objects, everything that you might want to capture. And at this point, I didn't even know how many objects that would be. So that'll be the first part of the journey, is figuring that out. So that's what led to this book. the astrophotographer's universe. So hopefully you can benefit from my insanity here, and I can answer some questions that maybe you've wondered about, which are, am I ever going to run out of objects to shoot? Like, how long can I keep doing this hobby of astrophotography? Does it end? Do you just get to everything? And once you've shot all the really common objects, so to speak, what are the hidden gems out there? What are the things, the objects that maybe other people are missing that you can go image? Or maybe you just wish somebody put all this stuff into a book and rated it for you so that you could sort them all. This is the process that we're going to go through over the course of this presentation. This is what I went through. So first thing I did was create a list of all the catalogs of visible light objects, take all those objects within them, dump them into one big master list, deduplicate that list, and then say, okay, well, what are actual objects that you might want to image? What are imaging targets here? Then rate them all, take pictures of all of them if possible, do some research on each one and write a short little encyclopedia type entry for each, notes on what's around it, how you might want to frame it, processing tips, things like that. Put all that into a book, put all that into an app. 5 years ago, this seemed doable. And I'd love to say that like I laid out a clear plan like this, but it just sort of evolved over time. But yeah, this seemed okay. I thought I can do this in 2 years. Here we are 6 years later, and it's finally done. So one of those typical things where if you'd known how long it was going to take, you might not have started it. But it starts with the first question, which is how many objects are out there? If you go online and you look on Simbad, Vizier's list of catalogs, it's crazy. There are actually 27,000 astronomical object catalogs out there, which seems a little ridiculous. Now, to be fair, a lot of them are catalogs of stars in a particular area, or their globular clusters, in the vicinity of one galaxy, or their radio targets and things like that. But regardless, there's over 20 million objects. So that's obviously not going to be a feasible number to work with. So I gathered up all of the major, so to speak, catalogs of objects and said, let's start here. And I won't go into details of this, but I sort of arranged them cleverly in a little periodic table of deep sky object catalogs. And essentially you sort of have time running from top to bottom. And then they're grouped. The more modern catalogs are grouped and color coded here by object type, right? So the older catalogs, they didn't even know what they were looking at. They thought, there's stars and there's things that aren't stars. And then we learned there are galaxies and nebulae and things like that. And so now we have much more logically designed catalogs. But okay, I said, these are most of the catalogs you might want to ever consider an object from. And some of them you may not even heard of before. But these are pictures you look online, people reference these catalogs. So how many objects does this add up to? Well, there's obviously some duplication in there, but there wasn't as much as I hoped. So I thought this would eliminate a lot of things, but just having Claude here actually did this analysis for me to say, like, what are the number of duplicate objects? It wasn't as great as I'd hoped. So that didn't reduce the number of objects tremendously, but fundamentally, even if you take out the Uppsala Galaxy Catalog and the BDSL, which is a catalog of objects and stars in the Magellanic Clouds, you still have over 27,000 objects. And that's just too big of a book. I don't have a whole lifetime to do this. We need to get to something a little more reasonable. So mainly, the first thing that came to my mind was size, right? You're not going to image really, really small things. Even if you have a giant telescope on Earth, unless you have exceptional seeing every night, really the atmosphere sets a limit on how small of a thing you can feasibly image. So I asked myself the question, like, realistically, are you going to look at galaxies that are 3 arc minutes across? Probably not. There might be a few, but you're not often going to dedicate an entire image, an entire night or more of exposure time for a single tiny galaxy. Same thing goes, there's a ton of really tiny planetary nebulae out there. If you have arc-second seeing and arc-second and resolution to support arc-second seeing, which would be exceptional in both cases, you're still looking at 60 pixels per arc minute. So like these, even if you did capture a great image, it's not going to be very big. So I set some thresholds here. So we said spiral galaxies, those we're going to include in this book everything 5 arc minutes in diameter or greater. Planetary nebulae, acknowledging they're smaller. We're going to definitely include everything over 3 arc minutes, and we'll pick some others in addition. And then reflection nebulae greater than 5 arc minutes. I said a higher number. I said a 10 arc minute number for elliptical galaxies. Maybe that's just my bias, but I've never looked at an image of an elliptical galaxy and gone, wow, that big fuzzy blob just blows me away in an image. So I want to include them. And there's some, really bright galaxies in Virgo, for instance. They're kind of interesting, but like for the most part, I'm not going to include as many. So I'm going to say elliptical is greater than 10 arc minutes. And then open clusters, we're just going to say all-star clusters, we're going to include them greater than 10 arc minutes and hope that most of them are good. A lot of them are not, but we're going to just say, when you look at a star chart as an astrophotographer, you might open up a copy of your favorite star chart and look, and you see all these potential targets on there, and a lot of them are going to be open clusters. And at least this book can help you say, oh, wow, okay, that's not a particularly interesting open cluster. So we're going to include everything over 10 arc minutes. Then we're going to go back and we're going to add in a bunch of stuff. So we're going to add in objects that are well known but small. So who can we can't include the ring nebula, right? Then there's tons of small objects, especially planetary nebulae, that are just really interesting that we want to include. We're going to, there's just some objects that are very interesting. There's some ARP objects where galaxies are colliding that we might want to include that are small. We're going to, for completeness, we're going to make sure that we've got some catalogs that are complete. So we're going to have the whole Messier Catalog, Sharpless, RCW, Bergh Catalog, nearly all of the Abell Planetary Catalog. So I only excluded things that were smaller than 1 arc minute there. Any emission nebula greater than 5 arc minutes in the NGC or IC catalog. And then I went through and I picked objects based on their photogenicity, so to speak, from the Lynds Catalog for bright nebula, dark nebulae, Barnard's dark nebulae, Cometary globules, the Green's supernova remnant catalog. I included every single green supernova remnant that has a known optical component. So you do all of that, what are you left with? So can we get this to something more reasonable? Yes, the answer is yes. We can get that number down to 1,732 objects. So that's, I said, okay, I can do this, all right? And by the time I figured out I had 1,732 objects, thank goodness I'd already imaged a couple hundred of them and written some of these things up. So there's no going back after that point. There's another question, not a question that you have to think of, but also these objects all have multiple names. So I had to come up with a hierarchy for like what to call them fundamentally. What is the main name you're going to list them under? So obviously, if it's got a Messier or an NGC designation, we're going to lead with that. But in researching, you'll find that a lot of the objects that we refer to as astrophotographers, we refer to by their NGC number. Oftentimes, that's just the open cluster at the center of a nebula, if it's a nebula, because back in the day, they were looking through much smaller telescopes. The NGC was done entirely visually, and so they often couldn't see that there was a nebula there. So in that case, I would use the Nebula catalog often to determine what name we should give that object. And then I kind of created a hierarchy within the different categories of objects to say, if it's got a Sharpless number, we're going to use the Sharpless number. These are all cross-referenced, of course, but in doing this, it gave me a sense of how much overlap there is and in all the different names and how many names it seems like every object actually has. So in doing that, look at that. We've just done a ton of work. We've checked off the first 4 things on the list. Now we've got to go take pictures of them and we've got to rate them all. So taking pictures of these objects, obviously they're going to be northern hemisphere, they're going to be southern hemisphere, they're going to be spread throughout the year. There's only so many clear nights. This is going to be a multi-year task. You can tell right from the beginning. So I've got a backyard here in Pennsylvania. I've got maybe 3 good nights a month on average, I'd say. And it's 4 to 5-ish, something like that. So mostly narrow band. So there's my FSQ 106. I've got a TS Photo Line 130. Those are the 2 workhorse telescopes in my backyard. In the middle is the most recent addition. So a year ago, I acquired a Tech 160 at Utah Desert Remote Observatories. This picture highlights a very important thing to do to improve the quality of your images, or at least I like to think it improves the reliability of your system. Because every now and then you need to hug your optical setup. It's got to be loved. It's got to know that it's wanted so that it doesn't break down for you when you're 3,000 miles from your scope. So that's my view, at least. That's me hugging my telescopes right after I bought it. And then also for the southern hemisphere, obviously I share a scope at Deep Sky Chile. I think this is a great way if you're not ready to jump into the cost or logistical complexities of a remote telescope. It's great to form a group of people. So there's like 4 or 5 of us get together, rent a pier, and send a telescope down to Deep Sky Chile. So I've been doing that for several years now. So in the end, right now I'm sitting at over 6,200 hours of exposure time, taking well over 5 years right now. And that number is growing. So I'm going and filling in gaps and taking pictures and improving them over time. So what makes a great object? If you're going to rate them and give them a subjective rating of whether or not it's worth your time, and I call this this is the potential of the object. In my view, when you look at AstroBen and you're scrolling through these things, what makes you stop? The 2 main things that make a deep sky object beautiful are color and structure primarily. So then in my system of rating these things, I said, okay, if it's colorless, that's the worst category you can be in. A lot of objects have 1 color. That's great. We've got some color there. And then if you've got multiple colors, especially contrasting colors, excellent. That's going to make a good object usually. The other is structure. And here's going back to elliptical galaxies. Elliptical galaxies, there's not much to look at. It's just kind of a blob. It's fuzzy. It never resolves into anything sharp. Spiral galaxies then are typically going to rate higher than an elliptical galaxy. And then spiral galaxies that have complex dust lanes and prominent H2 regions and really interesting structures, those are going to rate the highest. There's some other parameters here. So there's a bit of a thumb on the scale for brighter objects and larger objects. These are typically like beginner objects, but also when they're brighter, you can just get a better image, with fewer nights or fewer hours of exposure time. The other thing I think that goes most underrated is a sense of depth or dimensionality. That it doesn't just look flat. A lot of astro images just look like a flat thing. And when there's a sense of depth that you can see that there's a back side of the galaxy and a front side of the galaxy, or you can see that nebula has a spherical shape, or it's got something further from you and something closer to you. That sense of dimensionality, I think, is one of the big things. And then a smaller part, but some objects are just interesting astrophysically, or they've got a cool name and they change over time, or there's something about them that when you show someone that image, it's like, well, that's an okay image, but let me tell you about this object and it's really interesting. There's kind of bonus points for that too. So of course this is subjective, but I think we can agree that, for instance, in the Messier Catalog, M40, 2 stars, they're not even, it's a chance optical alignment. It's not even a double star. I'm going to say that's like the worst object in the Messier Catalog. It's not interesting at all. And I think we can all agree that something like M42, wow, like that, you just almost can't get a bad image of that. So obviously there's a lot of subjectivity between these two, but I don't think anybody out there is putting M40 above M42 in their rankings of what's a good looking object. So this is a rough estimate. So I just rated each object as I took the pictures. I looked at other people's images on AstroBen in particular, said like, maybe, maybe my scope doesn't have the potential for this. This is all assuming for every one of these objects that you have adequate equipment, time, and sky conditions to capture that object. So if it is a small galaxy, it could be a 5-star object if you have a CDK. It might be a 2-star object if you're working with a small refractor. So this is assuming you have the best possible equipment for that, and you have the time and hopefully dark skies and able to capture it. But this is when I did this, about 6% were in this exceptional category. I used the Amazon system of ratings because that's what the world we all live in now. 4 stars was excellent, and these are beautiful objects, but don't fall into that exceptional category. The plurality were in this middle category of worthwhile, like it's worth your time, but it doesn't stand out. And there's a lot of other objects that might be similar. So this would be a lot of galaxies in this category, for instance. There's a lot of spiral galaxies. There's just so many of them. Globular clusters. There's so many of them. But unless they had something about them that stand out that could move them into the 4-star category, I didn't move them up. 2 stars was, they're out there. It's not going to be a bad image, but maybe it's not the best use of your time. And then 1 star was, please do not bother taking a picture of this. I can't imagine why you would want to do that. I'll pause here. Any questions coming in the chat since I can't see the chat right now?
Nothing so far, Charlie, but we're watching it. Oh, there was a comment. M40 is the most ridiculous Messier object.
Yeah.
I think we all kind of agree.
Yeah, and you know what? Messier even knew it. Like he notes this. Messier was not under any delusion that that was a potential comet, right? Like he knew it. He was simply copying it over from Hevelius's data, and Hevelius had said he'd seen some nebulosity here, and Messier basically said, "I don't see anything here, but I'm going to put it on my list because it sounds like partially he was padding his list there at the end, but also." I don't see it, but hey, I'm working with a small scope, and this other guy said he did. So not Messier's fault, but I agree 100%. It is, without doubt, one of the worst objects you can possibly waste your time on.
I have a question before you move on.
Sure.
So your rating system, that all depends, as you said, on the equipment that you're using.
Yes. That's why I call it an image potential rating, right? So assuming you've got the right gear, you got dark skies if it needs dark skies, etc. The best image you could possibly get of this object kind of falls into one of these categories.
Thank you.
Mm-hmm. All right, so let's look at a couple examples here. So I mentioned before, so open clusters. M39, this is a Messier open cluster, but I know you can put diffraction spikes on this, like if you got a Newtonian or something, and it can look nice. But for the most part, like it's just some slightly brighter stars among some background. It's not particularly great. So most open clusters, I scored in the two-star range. However, not all open clusters, right? So there are other open clusters. I think M7 Ptolemy's cluster, really visually interesting, right? First of all, it's very bright. It's got a tiny bit of color contrast. It's got a couple of orange stars amidst the blue stars. But most importantly, it's sitting against a really interesting background of the Milky Way. You've got some dark nebulae around. So it's got some texture to it. And there's definitely a sense that these stars are in front of that background, right? So it's got a little depth to it. Same thing for M6, right? Sits right against the Milky Way. There's a lot of hydrogen alpha in the area. It's a little bit more sense of depth. And then my favorite, M35, right? Huge sense of depth here. There's clearly a group of stars as an open cluster M35 that's closer to you. And you get this sense of like, oh, I can almost fall into this picture because I can see that in the background, there's NGC 2158 back there, right? So this is a really nice combination of objects. Globular clusters. Most of them I rated 3 stars. The reason being, actually, they're quite nice, but they all kind of look the same. I used to, when I give this presentation live in a room, I'll give $20 to anybody who can name this cluster, right? And it's like, all the globulars look pretty much the same. So this is N55. So Omega Centauri being one of the big exceptions, like that one certainly stands out, and you can't miss it. But for the most part, good-sized globular clusters, they're worth imaging, but maybe not the first choice in a given area. Elliptical galaxies, here we go. M84, meh. All these kind of score in the two-star range, but sometimes they're in nice groups and they're really bright. And there's a lot of them. Think Markarian's chain or something like that. That can definitely raise the rating of something. And then I faced the challenge of, what do I do with all of these small-ish galaxies? There are so many in the NGC catalog between 5 and 7 arc minutes. So almost all the images in the book were taken with the scopes that I showed you. I rented some time on iTelescope to get some larger scopes for some of them, but the vast majority of images in the book I took with 5 or 6 inch refractors. And you can see the detail that you can reveal. It's quite nice with a 5 or 6 inch refractor. To be fair, under really good skies, especially at deep sky Chile. However, you're really pushing the limit here in terms of like these images actually aren't that big. I mean, these are probably 1,000 pixels across or something like that. Not particularly huge. So I'm going to go back to that assumption. I'm going to assume that these are good objects for me. They might actually be a great object if you had a CDK or something like that. So I'm going to err on the side of giving these a higher rating. So that's my gift to you, is that you officially have permission to say that, ugh, I need a bigger telescope, right? You have to match these telescopes with the objects. And if you're going to image all these objects, you're going to need bigger telescopes. You're going to need smaller telescopes. I always try to throw that in there. I hope it helps somebody when I present and I say that. There are also a ton of H2 regions, so emission nebulae out there. So I mentioned earlier that I wanted to include the entire Sharpless catalog. The Sharpless catalog, as we'll go through in a minute, has some amazing objects. It's got a couple hundred pretty mediocre objects, though. So these are the red blobs, I call them. They often have not much going on in the way of structure, kind of one color. These are older diffuse H2 regions, so there's really just hydrogen alpha that you're going to get. You don't pick up any sulfur or oxygen in these. And so, like, frankly, they're not worth seeking out. So I put these as 2-star objects. And then the final category are a couple of them. So this NGC 2419 being a great example. So this would normally be a 2-star object. It's hard to tell here. It's actually a very small globular cluster. However, it's got a neat story. Astrophysically, it's neat because it is thought to be a captured globular cluster that came from Sagittarius dwarf galaxy. Our galaxy stole it. So it kind of got ripped away. The other thing is it used to be called the intergalactic tramp, but somewhere along the way, the connotations of the word tramp changed, and now we call it the intergalactic wanderer. So, like, it's kind of got a cool story. I think I bumped this one up to like 3 stars from what might normally be 2. Okay, so look at that. This is so easy. We've already checked off like 7 of the things we needed to do. So we've got all this data. We're working on all these write-ups. The big question is, how am I going to order these things? So a lot of books group them, might sort them by constellation, sort them by RA, but you have 1,700 objects. You got to make a choice here. So I could have done it by right ascension, and that's nice because it kind of works you through the year, and as you work through the book, you're kind of working through the seasons. Problem there is you're grouping everything from the North Celestial Pole to the South Celestial Pole as you go forward. A lot of books use constellations. It's nice because it creates obvious chapters. You got these nice chunks of objects. The problem is if you're looking up an object, people don't usually know what constellation every object is in, except the brightest objects, the most common ones. So then you have to go look that up first before you go find them. And constellations kind of arbitrary borders anyway. The method I chose, which I haven't actually seen done much before, was I actually did this by catalog. So at least for modern catalogs, this allows us to group similar objects together. So like the Sharpless catalog is 98% emission nebulae, right? So for emission nebulae, you're probably going to use narrowband filters and things like that. So it does have some logic there. It also allows me to do a little bit of a historical approach, tell a little story about the history of the catalog. The challenge, though, is that, as I went over earlier, there's a lot of duplication. So objects have multiple names. And at the beginning of each chapter in the book, I had to put, if you were looking for Sharpless whatever, and it had an NGC number or a Messier number, refer back to this chapter. So at the beginning of each chapter, I had to cross-reference all this. There's no perfect solution to this problem. Probably electronic resources are even better because it doesn't have to be sorted in this particular way. But when you're producing a book, I had to make this decision. So this actually took a while to hash out what this was going to look like. And now that I've chosen this approach of grouping objects by their catalog, the rest of this presentation, we're going to go through a few of those catalogs, some of the primary ones. I'll just quickly give a brief history of the catalog. And what I want to do is show you some of the obvious highlight objects, and you're probably going to know most of them, except we get maybe some more obscure catalogs. But I want you to think about and take note of the overlooked objects, because I think that's what's neat, is like once you're a year or 2 or 3 into astrophotography and it's summer and in the Northern Hemisphere and the North America Nebula is swinging back into view, you're thinking, okay, great, I need to go take a picture of that. At some point, you're going to go, this is the 6th time I've taken a picture of the North American Nebula. Should I be taking a picture of something else? Surely there's something else interesting. So some of these more overlooked objects, and the reasons I find that objects go overlooked is that they're really faint and people lose the dedication to say, I don't, this thing's just going to take 20, 30 hours of exposure time to even see. I don't have that kind of time. I don't get that many clear nights. They're too large, so you might need just these large faint objects you need a wide field of view for. Southern objects get neglected just more generally. So 88% of the world's population lives in the northern hemisphere. Only 12% live in the southern hemisphere. So there's a huge bias toward the northern hemisphere. And then the most interesting was there's a lot of amazing objects that live next to an even better object. So Sharpless 119 being an example. North American Nebula is right there. Everybody swings a telescope to that. You swing it 2 degrees to the left and you can pick up Sharpless 119, and it's a beautiful, much fainter object. Anywhere else in the sky would get far, far more attention, but it's just too easy to take a picture of the bright thing next to it. So if you live next to a celebrity, nobody pays attention to you. So let's start with the Messier Catalog. The original Messier Catalog has 103 objects. Actually, the original had 45. 19 of those were Messier's discoveries, but he gets a lot of credit because, yes, he was working from some other people's data, but he actually went back and remeasured everything, which a lot of his the data he was getting weren't that great. And he accurately measured and posted exact coordinates for all of these objects. People say that this was a list of objects that he was a big comet discoverer, and he was making a list of things he didn't want to mistake for a comet. But it's also true that he knew he was creating a list of things that are not stars in the sky, and beyond just his own personal list of things that might look like a comet. And the reason you know that is because he had the list at 41, and Le Caillé had a list of 42 objects that had already been published out there. And so he dumped in 4 additional really common objects. And that's why Messier 42, 43, 44, 45 are really bright, really commonly, really well-known objects, because he wanted to get his list pretty clearly has a higher number than Le Caillé's object of 42 and got it to 45. 9 years later, it took a really long time, so he published this in kind of an almanac of the time. He added 23 more. He tightened up some of the descriptions and things like that. And then the final version, they got to 103 objects, was in 1781. And this was mostly in collaboration with Pierre Messier. I'll note here M102 and M103, he did not provide coordinates for, and that caused problems for centuries of historians trying to figure out exactly what he was referring to. I think we're pretty clear on what those objects actually were, but remember the way they did things at the time. He was measuring off either a reference star or he was measuring off of the edge of a chart. So he had these charts he was working from, and so he could be off by 5 degrees, or he could be, anchored to the wrong anchor star when he was measuring. And so historians have gone back and I think figured out what all the objects are at this point. They couldn't just tell the computer to point a certain way like we can. So he had 103. We've since expanded that all in the 20th century. So M104, he'd written in a handwritten in his personal copy. So Camille Flammarion said, we got to add that. Helen Sawyer Hogg added, or at least proposed adding 105, 106, and 107 because Pierre Messier had sent him a letter that we have possession of. M108 and 109 were added in a Sky and Telescope article by Owen Gingrich, and they're mentioned in descriptions, but not actually itemized. And then finally, and most controversially, M110 was added. It's not even actually clear what the reference is. It's most likely Kenneth Glenn Jones's book from 1968, although I keep seeing 1966 as a date that, well, he drew M110 in his drawing of M31, so we should add that too. Astronomy magazine rejects 110 to this day, as did Patrick Moore and Burnham in his Burnham Celestial Objects. But in general, I think we all agree 110 objects is where we stand for the modern Messier catalog. And on the left, you can see, yes, there are a few duds in there, but for the most part, there's a ton of great objects here, and you probably know them, right? There's also some oddballs. There's a star cloud, which is really just a patch of bright Milky Way. That's M24. There's M40, which we've discussed. There's M73, which is the second lamest Messier object. Also, it's 4 stars. And again, subsequent research has shown they're not even together. They're actually just a chance optical alignment, so not even a real object. However, there are some great objects. You know these. I don't need to talk about these. Some of the greatest objects in the sky. They're big. They're bright. They're the sort of thing you would have picked up with a 2-inch telescope from France in the 1700s, right? They're that big and that bright. And, you know, obviously Messier didn't see them like this, but these are just some of the highlights. My personal favorite, at least right now for me, M78. And I like this because it illustrates what I was talking about before. It kind of checks all the boxes. You've got multiple colors. You got the red and the blue contrasting, even a little bit of brown in there. You got red Herbig-Haro objects. You've got tons of structure. You've got these dust lanes cutting through, and even a sense of dimensionality in the sense that these look like clouds that actually have some dimensions to them. So this is probably, of the Messier objects, my favorite. If there was an object that is overlooked, it's hard to imagine anything in the Messier catalog being overlooked. I'd probably nominate M83. Beautiful galaxy, but pretty far south. I'm actually really impressed with all the southern objects that Messier picked up, that he was able to pick them up from Paris. They would have been right along the horizon for him. But M83 is the closest thing maybe to an overlooked gem in the catalog, but even it's quite well imaged. The next catalog to go to is the NGC. So the NGC was primarily discovered by the Herschel family. So William Herschel, with his sister Caroline, you know, dutifully taking notes and also scanning the sky as well. Together, they notched 2,400 objects, about a third of the catalog. His son then carried on the legacy, traveled to South Africa to take to view objects from there, adding 1,700 more objects. They didn't miss, but in their sweeps had limited coverage of a couple of areas. I've called them out here. I call them the Herschel holes. I've just made that up, but it's just like some areas where it was the only gaps where anyone else even had a chance of finding anything. So you do have some astronomers that are less known, Albert Marth, Lewis Swift, adding in a couple hundred, but there are about 100 contributors in total. Dreyer had to synthesize all this information, and varying levels of quality of information he was given. Do not envy this man's task. This took over a decade for him to consolidate this information together into the 7,800 objects that we have. There were tons of errors to be expected, most of them passed to Dreyer. And we've spent centuries cleaning this up. I would say right now, Wolfgang Steineke's revised NGC IC is kind of the definitive source for what we've got. And, you know, there's still a couple hundred duplicate objects here. But with this many objects, it is obvious. I can't even call out all the highlights. I will say it's mostly galaxies, though. So the NGC is 78% galaxies when you do the math. It's kind of crazy. And sorry, this is actually counting. Yes, this is from the open NGC data. The number of highlights are astonishing. The ones on the left here are the ones that I rated 5 stars. There are innumerable 4-star objects in here as well. Just throwing a few of them on the slide, just as a reminder of how great the objects in the NGC are. If I had to pick a favorite, my personal favorite, the Angel Nebula, NGC 2170, again, lots of colors, lots of structure, sense of depth to the image. Almost looks like an impressionistic painting to me. You even see some purples in here. This is an RGB image. You just don't, colors you don't even see that much in the dark, in the night sky. Overlooked objects in this catalog. Also, there's just so many objects there. I think that there are over 500 from the NGC catalog in the book. But there's some really interesting galaxies. The first 3 of these are galaxies that are somewhat overlooked, at least. NGC 3486. It's almost on the border of spiral and flocculent, right? You've got, I think I can count like 12 arms there. You got some of these barred spirals like 1530 and 4731. 4731's asymmetrical. It's been disrupted somehow. Just lots of interesting galaxies. I'll also say though, there are quite a number of really pretty planetary nebulae in the NGC catalog. So 5189 being one of my favorites. So these beautiful bipolar ones where clearly you've got, you know, two stars in orbit, and the planetary nebula is being sort of distorted in that bipolar structure by that motion, forming that really interesting S shape. And again, all these images here were taken with 5 and 6 inch refractors. So these are all well within the reach of normal mortal telescopes. Any questions? I'll pause here for just a minute.
It takes us a second to unmute ourselves, Charlie.
I totally understand. I used to live on Zoom.
There's plenty of chat. I think your partner is on the chat.
Oh, excellent.
Most of those questions are being answered, so I think we're good.
Okay, awesome. Okay, we'll save time at the end then. Okay, the IC. Okay, so I mentioned that drivers spent more than a decade, you know, taking all this information, trying to check it all and remember, he's trying to dedupe, and he can't just ask Claude to go dedupe. He's, you know, got these handwritten notes from people, and they might have, you know, bad coordinates and everything. So he spends over a decade doing this. While he's doing that in the 1800s, they invent photography and start applying photography to the night sky. And so by the time he completes it, they call him back and they're like, hey, we've taken all these pictures and we've discovered a whole bunch more objects. Can you do this again? So that's the index catalog. This comes out in a couple more volumes, and it is another 6,000 objects. It's a bit disappointing though, I'd say, from an astrophotography perspective. It's 75% galaxies, similar to the NGC. However, 15 of that 4,100 are larger than 5 arc minutes. So basically, all the good stuff has been picked up by the visual observers in the NGC era, and then they come back through with cameras and they start picking up a lot of the really small stuff. There's only 8 globular clusters of any size in the IC, but what it did pick up. So if you look at the ratio here, there were almost 6,000 objects. Only 93 are included in the book because most of them just are, you know, well below the size numbers we were looking at before. However, with photography, they were able to start picking up some of these large emission nebulae, and that's what really stands out about the IC. So the 5-star objects from the index catalog are some of the biggest big bright emission nebulae that you know well. I picked some representative examples to show here, but especially in the northern hemisphere, this is a lot of our big bright nebulae. If I had to pick a favorite right now, I'll call out the Cocoon Nebula here, right? Again, multiple colors, lots of dust, lots going on. This picture literally is from last week. I think I took this like 3 weeks ago and processed it last week. So maybe it's just recency bias, right? This is one of my favorites. But there's also some overlooked objects, some highlights. I think 4995 is just interesting looking. There's not quite anything else out there I know like this object. They call these Orion's Tears. So this is some of the ICs in the 424, 423. Really difficult to shoot because the glare from Alnitak is a big problem. But if you can capture these under dark skies, I think just they've got a really unique look to them. These small molecular clouds. The Sharpless catalog. So this is Stuart Sharpless. So this is the first of several catalogs that were created from the Palomar Observatory survey. So there's a 48-inch Schmidt telescope. They covered the entire northern hemisphere sky down to 27 degrees into the southern hemisphere. Stuart Sharpless went through them and carefully compared the red plates and the blue plates and said, okay, we're going to try to find all the emission nebulae here. So he started that in 1953. That was the Sharpless 1 catalog, which you never hear about. In 1959, he expanded that, and that's the 313 objects that we talk about today. 233 of those were discovered by Sharpless, and he acknowledges the work of some other people that had done some work before him to discover some of these objects. But a lot of red blobs, as I mentioned earlier. However, a lot of the greatest emission nebulae out there. these are the 5-star objects, so to speak, actually, as rated in the book, and some representative images of these. You've probably seen a lot of these, and these are the ones that you often don't even see on star atlases until recently, at least. So, like, atlases of the night sky were typically designed for visual observers, and so these things aren't even marked in a lot of cases in atlases, but they're the best targets possible for narrowband imaging for astrophotography. Now that we can go look so much deeper. Some overlooked objects, some hidden gems, and there's a lot of these. So Sharpless 34, this thing's huge. I think this, the field of view here is like 2 degrees by 3 degrees. So this thing spans like 3 degrees. It's an absolutely huge. It's fairly faint, but it's got a lot of structure. It's a fairly interesting object. Rarely see images of this one. Sharpless 54. You do see some images of this one, but it's a pretty neat object, and it's got oxygen, sulfur, and hydrogen signal. Sharpless 126, I call this the scarlet letter. It looks like a big red letter A to me. The challenge of this object is that you need H alpha data to capture the red part, but then you need RGB and potentially even luminance data and dark skies to capture the molecular clouds that are sort of entwined with it. But the potential is really high for this object. Sharpless 119, this is the one I mentioned earlier. This sometimes called the Clamshell Nebula, right next door to the North American Nebula, but image probably 50 times less often than the North American Nebula. 216, this is actually a planetary nebula. I think it's now thought to be the second closest planetary nebula to us. That's it on the left. On the right, it's actually a supernova remnant. I think that's Sharpless 217. But very, very faint, very, very large. The field of view here is like 3 degrees. So a very big, but very faint object. Sharpless 263, I think this is sometimes people call this the Strawberry Nebula or Raspberry Nebula. Also challenging because you've got a reflection nebula and an emission nebula component. The reflection nebula requires dark skies and RGB data, and then you can add in the H alpha for the emission nebula underneath. Sharpless 280. So this is, again, suffers from being next to a celebrity. So this is just south of the Rosette Nebula. It's almost as big, not nearly as bright, but again, you've got a beautiful nebula down here. It's got oxygen, it's got sulfur, it's got hydrogen, it's got all the major channels. There's a lot you can work with this object, and it's quite large. All right, the Southern Sharpless, the RCW catalog.
Charlie, before you move
Yes.
on, sorry, took me a moment.
No problem.
A question has come up, and I think we're all kind of wondering, how much time do you put into each object, and how do you decide about that?
Yeah, great question. Let's see, the least would be open clusters, because and open clusters are great because if it's a full moon, like, doesn't matter. Like the stars you're trying to capture are point sources and they're bright enough that it's not a problem. So most open clusters, even globular clusters, probably an hour and a half of exposure time for most of those. Most of the nebulae you see around 10 hours if it was narrowband, especially if it had sulfur, hydrogen, and oxygen. I needed 3 to 5 hours of each of those channels. Then like it goes up to 40 hours for the supernova remnants. It varied by object. Like anything, you shoot it, you process it. If your signal noise ratio doesn't look like it's there, you can see there's more, that it's going to yield more with more data, you go shoot more. The problem here for me was that I'm trying to shoot 1,700 objects, and so often by the time I realize that I need more data, the season has passed. It's already passing out of the sky for that time of year, and I'd have to come back the next year and reshoot it. So I was just making notes to myself, like, this image is marginal, shoot more of it next year. And the problem, of course, with all this, and everybody knows this, it always gets a little bit better with more data, right? So it could always be better. So the question was, which of these objects am I going to dedicate the next year's imaging time to make better, versus which ones am I not? So I I would say, yeah, a lot of I would say standard was 90 minutes for most star clusters. A standard galaxy might be 3 to 6 hours. Most of if it was a nebula I was dedicating any time at all to, is probably 8 to 12 hours, something like that. And then it just goes on up from there.
Thank
Great
you.
question. Okay, so the southern Sharpless, so RCW was going to cover everything Sharpless did further south, but there's a lot of overlaps. There's only 90 objects in the RCW that weren't listed elsewhere. But there's some interesting stuff, and they're kind of all overlooked. It's hard to say there's highlights in the RCW catalog because, frankly, they're all kind of overlooked for the most part. This RCW 58, which is also a Wolf Rayet 40, really cool, really interesting. Obviously shaped like an eye looking at you. But there's some sulfur, there's some oxygen signal in there. You can see faintly. It's on this background of dense stars. Beautiful object. RCW 54 is this sort of really large complex of nebulae that have other catalog entries, but really interesting in the southern hemisphere. RCW 19, bright, nice structure, got channel data in all 3 channels, but it's really far south for northern hemisphere observers. RCW 35 is the red thing in the back, and that might normally not be that interesting, but it sits literally behind, and you can see that it's behind it, the Vela supernova remnant. And so there's some beautiful tendrils in oxygen that are overlaid in front of it, and the combination in that area is just, that whole area of the sky, the Vela supernova remnant, is obviously beautiful, but this particular area has a really nice contrast because of the RCW 35. RCW 113 is the nebulosity around the object we refer to as the dark tower, a particularly beautiful dark nebula that, again, kind of has a nice 3-dimensional feel to it. RCW 85, if this were in the northern hemisphere, like this would be, kind of a marquee object to shoot. It's got, great data in all 3 channels. It's got all of these doesn't look as good here, not well revealed in my image, but it's got these almost crepuscular rays that you can see where light from behind is being shadowed and kind of coming out in these rays just around the top of the nebula. Really stunning. Again, it's really far south. If this is in the northern hemisphere, people be shooting this like they do the Wizard Nebula up here. The Bergh Catalog. So this is the standard catalog for reflection nebulae. And basically what they did, they went through these 2 star catalogs, the BD and CD, about 50,000 stars, and said, we're going to look and see which ones have nebulosity around them in the blue channel. I do not know why. There were 158 in the publication. Somebody just added a 159 and it got added in. I'm not sure what the story is there, but it wasn't even by Bergh who published that, but there's 159. And then Bergh got together with Erbst and they published a vdBH for the southern hemisphere, and nobody seems to ever use that catalog, but there's a couple of decent objects in there. So these are all reflection nebulae. The Antares Nebula is Bergh 107. The Wolf's Cave area, this is Bergh 152. Beautiful area, but Bergh 152 is just that little reflection nebula at the head of the cave there, so to speak. There's some overlooked objects here, though, as well. So in the northern hemisphere, you have dark skies. Sharpless 202 is this big red blob up here, but Bergh 14 and 15, faint, but really nice color contrast in this area of the sky, if you can reveal it. Bergh 70 on the left here, and I put it in so you can see it in a wide field on the right. Really interesting, beautiful object. I rarely see images of it. It's challenging to image. It requires dark skies, and you got to combine narrowband and broadband data to probably capture it well. But it also suffers from being just adjacent to the Angel Nebula, which I showed you earlier. And so your attention's probably going to be drawn down there. But beautiful object. Another one that I've seen very few objects. This was a really long exposure. It took a lot to pull this out. I pushed the data really hard. But Bergh 80, like when I posted this in Astrobin, there were like just a handful of other images ever taken of this object. But there's actually really interesting structure going on here, and color and a lot. It's just a really difficult object. Okay, Lynds Catalog. So the bright and dark catalogs, LDN, LBN. Man, there's a lot of them. It's a hot mess in a lot of ways. The objects overlap. We don't actually know. We have coordinates, but we don't actually know which blob, so to speak, Lynds was referring to, because the coordinates got published, but the maps didn't. So I saw, and I think it was on this channel, that Rod Pommier's got the Beverly Lynds original tracings, and so we can hopefully at some point figure out exactly what she was referring to. But these are really challenging to use, but they are the primary designation for a lot of molecular clouds, and there are a lot of beautiful objects in here. So it's this crazy catalog, and only about 50 of them sort of made my list, but they are some really great objects. So some of them you might know. So there's the Gecko Nebula here on the left, the Rotten Fish on the right. You know, these are, if you have dark skies, these are very rewarding objects. The Boogeyman Nebula is in the LBN catalog. That's embedded in Barnard's Loop. Dark Shark, this is a very, very famous one, but if you look around the Dark Shark, that whole area of the sky is just filled with these really cool dust clouds. There's also some emission nebulae. So I'm not sure how Sharpless missed this one. LBN 234, moderately bright, very large emission nebula. But again, you've got all three narrowband channels. There's a lot to work with. LBN 902, really interesting object here with reflection nebulosity combined with some ionized hydrogen. LBN 331, these beautiful wisps. This one's right in Cygnus. Again, probably just suffers from being too close to so many, we're spoiled for targets in Cygnus. The Checkmark Nebula, LBN 534, again, molecular cloud requires dark skies. I think this is, all these molecular cloud images you're seeing are on the order of about 20 hours of exposure time, mostly from Utah Desert Remote Observatories, but worth the effort if you have the dark skies. LBN 640, this one I just highlight because I haven't seen very many objects that look anything like this. I'm not even sure what's going on, some sort of cometary globule type process, but really interesting nonetheless. Okay, Abell Planetary Catalog. So don't confuse this with Abell's much, much larger catalog of galaxy clusters. This only has 86 objects, but it's kind of, if it's a large planetary nebula and it wasn't captured by one of the catalogs we already mentioned, it's probably going to be picked up here. And that's exactly what I did. And there's a few. So the Medusa Nebula, that's primary designation is Abell 21, but there's some other hidden gems in here. Abell 78, Abell 31, Abell 35 there on the bottom right, super faint, really difficult object. But as you can see, again, you've got all the different channels going on there. I'll probably go back and shoot more data on this one. I think this is probably only order of like 10 hours. This probably needs 20, 30, 40 hours of exposure time to fully capture. Okay, Barnard. So Barnard's catalog is selected regions of the Milky Way. This is an early photographic catalog attempt. It was actually published after his death because he was so meticulous about how it had to look. They only got 700 copies printed because rather than using halftone printing, which was actually available at the time, he insisted that actual photographic prints had to be in there. So he's actually printing prints for 700 copies of books for every single page in this thing. So it's legendary how much effort he put into this. So he's at the top of Mount Wilson. I always tell people, I think this is the first example, at least that I found, of multi-night exposures. But this is in the film era. So like, imagine what that took, right? So in addition to sitting out there in the cold and taking multi-hour exposures with these like f1 and f2 portrait lenses, he's tracking the stars manually, right? He's manually moving this telescope and tracking. There's no auto guiding at the time. And on top of that, he's actually doing multiple night exposures. So Barnard was just superhuman in a lot of ways, and was able. And what's interesting is that a lot of the objects that were subsequently discovered in the 20th century, research has gone back, were actually discovered by Barnard beforehand, because he just didn't publish everything. He was just observing so many things and making so many notes that it was he kind of captured everything before anybody else could get to it. He just didn't publish it. So there's lots of highlights of the Barnard catalog. I'll just put Barnard 150, but you know of Barnard's E and the ink spot and lots of really interesting dark nebulae in that catalog. There's a lot of really interesting ones too. So out of the 300 or so, they're not all gems, but there's some really interesting stuff in there. Barnard 22, this has the little flame nebula in it. This is a really faint object to capture the molecular cloud aspect of it. Okay, Green's SNR catalog. So this is wherever you see an SNRG, that is Green's catalog. He's been maintaining this online since the 90s. He started it decades ago. Only about 100 of these actually have a known optical component to them. So I had to go back and research and figure out which ones had something you could actually image, because most supernova remnants are discovered through radio signal. So scanning through all those, there are some really faint but really interesting objects here. So a few of these you may have seen. So sometimes people call this one the Beta Fish Nebula. You can see it's primarily it's teal here, obviously, so that's going to be oxygen, but really faint, really intricate wisps of nebulosity here. I love this one. Another one, very faint, 206.9. I don't think this one has I think people might have tried to call this a trilobite nebula, something like that. I think this one's approaching 30 hours of exposure time. I don't remember exactly, but incredibly difficult. Had to push the data incredibly hard to get it. And then the one in Cygnus, when I took my first image of this in 2015, I think I found 2 other amateur images of it at the time, and it requires a large mosaic for most people. The circle at the top is the size of a full moon, just to give a sense of it. It's something like 7 degrees across. So this is a massive object. Parts of it are cataloged in the Sharpless catalog, but it's a really interesting object nonetheless. But I love the Green Supernova catalog because you're getting into stuff that's like 20, 30, 40 hours of exposure time to make a great image. So these are where the challenges lie. This is kind of the frontier in a lot of cases of astrophotography these days. The Cometary globule CG. So you may not have even heard of this, but these are basically Bach globules that have a streamer behind them. Almost all of them are in the constellations Vela and Puppis. There's not a single paper. It sort of got compiled over multiple different papers, but really interesting objects. CG1 and 2, that's a typo on the left. The Hand of God, or the Galaxy Eater, it's sometimes called, on the right. Really, difficult objects in the sense they require dark skies and a lot of time, but incredibly rewarding, beautiful objects. My personal favorite might be this one. This is CG31. I think there's just a nice sense of motion here and everything. But there's a lot to explore in the CG catalog. The objects in the Large Magellanic Cloud, I won't get into the different catalogs here, but this is just basically filled with overlapping bubbles of exploding gases and ionized gases here. So you're spoiled for choice, but they're all fairly small, right? You're looking at the Large Magellanic Cloud, which spans a few degrees, and then you're looking at objects within that. So obviously, highlights, you've got the Tarantula Nebula, N11, that's Henai's 11, but I could call out 20 or 30 objects that are similar to this, small but similar. Tons of opportunity for narrowband imaging. They're actually quite bright. All right, so the last group of objects we're going to look at, other catalogs. So everything you've heard so far has been from catalogs you've heard of, referenced commonly. There are actually some objects that don't have a catalog designation. Or they do, but it was added on later. But the real name, if you look it up on Simbat or whatever, is actually just says name, red rectangle. The Coalsack from the Messier Catalog. You'd think Messier would have caught that, but it's in the southern hemisphere, right? So this is one of those like star cloud type things, but it's a big dark nebula. The Serpens Nebula. that's just what it's called. It doesn't have another designation. It's pretty funny when you look it up. The professional appropriate name for it is Serpens Nebula. Of course, the Biela supernova remnant, large Magellanic Cloud, they don't have catalog designations either. They're just too large. Fornax dwarf spheroidal galaxy. I'm not saying this is the most beautiful object in the world, but these are the sort of things where they're at the frontier of astrophotography. They have a neat story in the sense that it's incredibly faint, these dwarf galaxies, and can you resolve them? And you can kind of see, you can resolve individual stars here. Baroness 147, the whole Corona Australis region is stunning. This is, I can't remember how many degrees across this is, but this is many degrees. This is a very large object that I think extends about 20 degrees in total. Baroness 149, you got a reflection nebula. This is a collaboration with Charles Pevsner. Reflection nebula superimposed on a dark nebula. Highly underrated object, I think. Brand 56, this is the sometimes a couple objects called the Misty Mountain. This is one of them. But this is the best part of the enormous Gum Nebula, which is the largest emission nebula in the sky. Probably overlooked mostly because it's southern. Incredibly overlooked Setterblad 51, complex of reflection nebula, emission nebula, and this is probably extended red emission, not normal ionized hydrogen, with some dark nebula and a molecular cloud. Just a lot going on. This is yeah, get this one, get in on this one while you can. CTA1 easily observed by northern hemisphere observers, but as I note here, this is 17 hours and I had to push the data to reveal it. So CTA1, this is the Caltech list of radio targets. This was the supernova remnant that discovered radio in the very early days of radio telescopes, and people didn't even know that it had an optical component for decades, I think. And so it's there. It's just incredibly faint, but really interesting shape, really interesting structure. A lot going on for those dedicated enough to find it. The Longhorn Nebula, fairly well known, but again, I said we were spoiled for opportunity in Cygnus, and so it's right there. I don't know how Sharpless missed it, but it's actually really neat, and it's got this real sense of dimensionality to it. Like there's you know, this doesn't look like a flat image. Gulbudagian's Nebula. So this is interesting because you got a molecular cloud, but it's being illuminated by a variable, and so depending on what year you look at this, or even what month, you may see a slightly different thing, or you may not see it at all, which makes it one of those objects that has a cool story. Hen 2111, this is a planetary nebula. This is not a great image, I will admit it. This is one of the ones I talked about earlier where I didn't realize I had a great object on my hand until it was too late in the season. So this season, I'm going to go back, I'm going to add more data to this. But this is by Hen Eyes, is the same person who cataloged all the N objects in the Magellanic Clouds. He was also an astronaut, interestingly. Ring galaxies in general are amazing. These are very small. You can see with a 6 or 5 inch refractor, you're not capturing a whole lot of detail. But Hoag's object, and there's a couple others. There's the, I forget what they call this in the spinning wheel on the right. The Ant Nebula, this is Menzel 1, really interesting, underrated, but very small planetary nebula. I think if you had a CDK, you could probably do something pretty amazing here. And I'm pretty sure there is a great Hubble image of this object. Araucaria, this is a, I won't get into the details here, but it looks like there have been at least 3 eruptions of this planetary. And you can see that those eruptions happened when the star was spinning at different orientations. And so they've, over the centuries, sort of got these overlay of different eruptions. Shapley 1, Spare Tire Nebula, underrated, not imaged enough. And also, if you capture in a wide field, you can capture another, I've neglected to put the name of it here, but there's another planetary just right nearby. But it's a very unique planetary, actually very bright. Wolfram 134, this is seen fairly commonly, and the deeper you image it, it's on the left here, the longer the exposure time, the closer you can get to revealing the whole circle. So here I only reveal an arc, but if you go in Astrobin, there are plenty of people who are dedicating 100 hours or more to this thing and revealing the full circle of it, which is super impressive, but you can also capture a nice wide field with the Tulip Nebula. Wolf-Rayet 8, this is HFG2, so this is one of several planetaries out there that form this sort of soccer ball or membrane look to them. Very rarely see images of these objects. Wolf-Rayet 102, same idea, but just a lot larger. And this is in Sagittarius. Like, you really don't see very many images of this object, but you can see how hard I had to push the data here. It's quite faint. And finally, to get back to the beginning, how many objects are worth imaging out there? So I said I had 1,732 total, but I also told you that maybe 1-star and 2-star weren't worth it. So what you're really left with, I think realistically, is a lifetime of objects for this hobby, because there are about 1,000, roughly 1,000 objects I rated 3 stars or higher. I think I've covered nearly everything that's out there worth imaging. There are probably a few large supernova remnants. There's new discoveries on Astrobin all the time, but roughly 1,000 objects. You think about the number of clear nights that you've got. You think about how you might want to go back and reshoot or go deeper on some of them. I think fundamentally, you could stay busy with this hobby for a lifetime with these 1,000 objects. So hopefully that answered a lot of your questions. Put my contact information on here if anybody wants to reach out. But yeah, I'd be happy to close out with any additional questions.
There's plenty of nice comments, Charlie, but I don't see any additional questions. I see the comment, a lot of us are making notes. Like,
good.
Oh, we didn't know about that one. And I've made a few notes myself.
It'll be on YouTube, I think, so people can go back and yeah.
Yep.
So sure they'll spot all the errors in it too.
What's next, Charlie, now that you've imaged the whole sky?
What's that?
What's next now that you've imaged the whole sky?
It's exactly what I was saying on that last slide. So there's like 1,000 objects, but you realize you can go back and you're like, ooh, I could do so much better on that one. I could do so much better on this one. And so 2 things I'm doing right now. I am going deeper on some of the objects that I felt I needed to go deeper on. And then I'm actually just filling in the gaps. So I think there are about 1,100 objects that I took images of. Some of the 1-star and 2-stars I didn't bother with. Kind of going back and just filling in the gaps to just take pictures of even some of those lesser objects. So thankfully, Chile and Utah have been offering me plenty of clear nights. My backyard here in Pennsylvania, not so much. But I'm constantly adding new objects and just going deeper on the others.
Have you thought about collaborating with others that have bigger telescopes?
Yes. So I was able to meet some people at NEAF and NEAC who had larger telescopes, and that's definitely what I want to do, especially for some of these. There's some planetary nebulae that I really want to go back, that I think there's some structure that could be revealed much better than a 6-inch refractor can do justice to. So yeah, great point.
So what's your focal length? 1,000, 1,200?
Yeah. So the Tech 160, I think, is about 1,200 with the flattener. TOA 130s around 1,000. So, and then for the bigger stuff, I've got the FSQ 106, which I can either have at 367 or 530.
Did we ask the question about let's see, whose question was it? John at Astro's question about integration time.
Yes, we did.
Yes.
Okay, sorry.
Yeah.
Charles, I had a couple questions. Really fascinating talk, by the way, and I'll be putting in a bunch of timestamps for the different catalogs and the 5-star point slides for people to be able to go look back at. So 2 questions I had. If you had to pick which catalog you think is probably the best for the Southern Hemisphere, do you have one in mind for that?
Interesting. A good question. I would say, so part of the challenge is that all the Northern Hemisphere catalogs kind of go down to like negative, to 20 or even 30 degrees south. And so you're picking up the best parts of the Milky Way are actually, visible from the Northern Hemisphere. So RCW is the obvious place to go there. But the NGC, so when John Herschel went to South Africa to sort of finish the night sky in the NGC, a lot of them got picked up in the NGC. So I would say RCW, which is the equivalent to the Sharpless, but a lot of the Sharpless objects are in the Southern Hemisphere. NGC, which covers everything. And then probably, after that, you're looking at the greatest thing that they have down there that we don't have, which is the Magellanic Clouds. And so then you're looking at the NGC Catalog of nebulae in the Magellanic Clouds.
So that pretty much leads me right into my second question. You obviously have a pretty extensive knowledge of these catalogs, and with that, I wonder, what do you suppose are some of the best places and ways to be able to make new discoveries?
Yeah. So the gaps that professional astronomers have is exposure time and short focal length. So what you see on Astrobin these days are discoveries of really faint supernova remnants that are really big. Like that seems to be the frontier. There are people doing amazing work on there. I'm incredibly jealous of them. They're making these discoveries. So one way to do it, and I think what in a lot of cases doing, is they're going back through like the SNRG catalog and saying, there's a radio signal here, but no known optical component. Oh, that's just because they haven't looked deep enough yet. What if we did 200 hours of oxygen exposure here in this part of the sky? We'll pick something up. The other thing I'll say, though, is that in the process of taking these pictures and trying to identify everything in them, I didn't count it, but there's probably 25 places where I just say uncatalogued object, 6 arc minutes to the left. Not everything is cataloged. It's not worth cataloging everything, especially in areas of the sky. I mean, at some point you get into a silly discussion of like, okay, well, this blob of molecular cloud, has this one wisp over here. Does that need its own, name? But there are you can make a reasonable case for a couple hundred additional uncatalogued objects out there. But the main place right now is supernova remnants and planetary nebulae. And the way you find them is long oxygen exposures, and just keep exposing and keep looking. I would have thought we would have discovered it all by now, but there's still every week something new popping up on Astrobin.
Have you looked at the work that Dressler and company have done?
Yep. So I think I put 2 of their objects in the book. Probably in future editions, I'll add more. The challenge there, though, is when you look at what they did, and they're like, oh, we exposed 200 hours to take this. I'm like, is this worth including? How many other people are going to dedicate 200 hours to this? Like, it's amazing that they did it. I don't know how many people are going to follow in their footsteps, But yeah, and they're beautiful. Some of the objects they're discovering are really, really pretty. They're just incredibly faint.
Thanks. It's a
Thank
really
you.
fascinating answer.
Yeah.
All right. Well, if we don't have any more questions on the YouTube or any more questions in the room, then I think we can call it an evening. Does that sound good?
Awesome. Thank you so much for having me. Really appreciate it.
Yeah, thanks so much for coming on. It's really fun to hear that talk again. And I'm furiously trying to take down targets and missing them. So I'm just going to go through your Astrobin and go pick up stuff. I go through your Astrobin and I go through Gary M's Astrobin for new targets.
Gary M is like the other completist out there. Gary's got even smaller objects than I have. Yeah.
Yeah, he goes after like little things for like a couple of hours, and then I go follow up for like 30 hours to go see what's there.
That's a great way to do it. Yeah.
So now I can add your Astrobin to my list of places I trawl through for targets.
Awesome. Awesome.
And
All right. Yeah.
and you can hang out with us a little bit if you'd like.
Sure.
Once
I'll
we
stick around for
close
5
the
minutes.
show.
Yeah.
Alrighty. I think we'll call it a night. So we'll see you guys back on July 19th to hear about the ASI Air and all the things that you wish you knew about it. And we'll call it a night. Good night, everybody.
Have a good night.